So the characteristic of coplanar concurrent force is that the force system is that resultant is also going to pass through the same point where all the forces are acting. Okay, so quite different from what we saw yesterday, right? Is what we are going to see today. This is called as coplanar coplanar. This is non-concurrent. Coplanar non-concurrent forces. So as the name suggests, all the forces will be acting on the same plane, but they are not acting on the same point, but they are acting on different points on the same plane, right? So let us see an example, right? So if this is a plane, right, we can see that the forces are acting at different points on the plane, right? You can see one force here. So the line of action for this force will be along this line. You see it's on this the plane, but it is acting like, right? There is another force which is acting over here. So it's still on the same plane, but you see the line of action is different, right? These two might meet somewhere, right? The forces might meet somewhere here, but you see now when I consider a third force, it's very clear that they are not going to meet. They are not all the three are not going to have the same force, same common point. So somewhere like this, right? So this the meeting point of these two will be somewhere here, right? At the same time, the other two will not meet on this plane, on this given sheet of paper, right? So you can have a different plane, different force acting, say, like this. So very clear that there are many forces on the same plane, but they are not meeting on common single point like the previous case. So such system is referred to as the coplanar but non-concurrent force system. All right, F1, F2, F3, F4, etc. All right, now, so how to find the resultant in such case, right? So we have the similar formula like yesterday, but it's going to be it gets extended. Some more points needs to be calculated from before we come to the conclusion that how to find out the resultant. So for a coplanar non-concurrent force system, the first point is the magnitude of resultant. This is normally denoted by R is equal to, once again, under root of sigma fx summation of the fx whole square plus summation fy the whole square, right? Same equation like yesterday, right? The next one is, once again, I'm going to calculate the angle, right? Theta is equal to tan inverse of summation of fy by summation of fx. So now the question comes, okay, r is this equation, theta is also same equation like we used yesterday. Then what's the difference? What's the difference between the forces, right? Multiple forces acting on the same point, and the forces are not acting on the same point, but they are located at different points. Okay, so now what's the difference? The difference is like this. Let's make a simple comparison, right? The simple comparison is, consider a scenario, say this is the first example. So in the first example, so all the forces were acting on a single point, right? Like this. Maybe like this. right? Maybe something like this. So we have many forces acting on the common point, right? And we know that even the resultant will pass through the same. Let me assume that I found a resultant and resultant is this one, right? Resultant will also pass through the same point. Now, in order to measure this resultant, okay, let me write the force names as well. So let me say the first force is F1, this is F2, this is F3, and a resultant. So resultant was something like this. So in order to identify which is the R, I just need what is the magnitude of R and what is the angle made by that particular R with respect to x-axis, right? So if I try to find out, right, the angle made by R with respect to x-axis, that is sufficient. So we found R and theta, right? So R comma theta, right? This itself represents the resultant. I don't need any other details. Okay. Now let's come back. Let's come back to the example of the coplanar but non-concurrent system. For example, let's take the similar case. Okay, so this is say x-axis, this is say y-axis. Now, right, I'm considering, let us say one plane over here. Let me say this is the plane. On this plane, I have many forces, right? Say one force here, any force can act at any point, right? So second force over here, and the third force at something like this. There is a fourth force which is acting, right? Or maybe like this. Anything which is on the same plane. Okay, right. Okay, now if I simply measure R and theta, right? You see, let me say there is a R and theta, right? So let's say we found that there is a R and there is a theta. R and theta could be anyway. So now also the resultant will be present on the same plane, but not there is, since there is no common point through which the resultant passes, like the previous example, what we see here, there is a, we are definite that, okay, this R passes through this point and, right, it has to pass through this with this magnitude and with this theta. R and theta given means only one force. There are, we don't have many forces with the R and theta value, but in this case, you see, there are many forces which will satisfy this condition. Let me assume that the resultant is, say, I measure that R and theta and I give one result. Say this one. I'll say that this is 1 R which makes a specific angle theta with respect to, this is the resultant. But is that the only answer? No. I can also have another force over here, right? That also has the same magnitude, same angle, because it is on the same plane, right? On the same plane, I can have multiple forces satisfying this condition. Okay, there are multiple forces which satisfy this condition. So I have to be more specific, right? Which is the R out of, maybe I have infinite number of R values which satisfy R and theta. If I simply find R and theta like using the previous formulae, I get, actually I have infinite solutions. On this plane, I have infinite R's satisfying this condition, because on the plane it can be anywhere, right? So you see, I need, right, something more. I need, right, I need something more, some more details about this. Okay, so that is, right, I can measure that using, so the force is actually located right over here. I can say that from a point, right, I can measure with respect to a point, I can measure it. All right, so with respect to a point, I can definitely say that, okay, let me say this is my, so I can definitely say that this is my point on which, from where I am trying to measure it. Okay, distance of, from, maybe this is O, right? From O, what is the shortest distance? If at all you say that if you are able to measure this shortest distance, then you see this is the only one force. I cannot have another force with the same shortest distance. Correct? I cannot have another R here which has the same shortest distance. Right? So that's the point. Right? So what we need now is that we need the shortest distance. And you can also measure the same thing using what is the y-intercept and what is the x-intercept. You see that if I have a force which is R, it has a specific x-intercept and it has a specific y-intercept over here. So either you specify what is the shortest distance, what is the x coordinate, and what is the x and y intercept of that force. If you are able to measure that, then you are actually giving a specific R. You are finding out the specific resultant, not the infinite number of common possible solutions. So in order to find that, we need some more detail, right? How do you find out the specific answer? By using the following formula. So the next part, I found the angle theta, right? After this, you see, we calculate the moments about any specific point. Then in order to find either the shortest distance or in order to find the, what you call, x and y intercept, we have to do the following. Okay, so next step, you calculate R, you calculate theta, and in the next step, you calculate the moment of all the forces about a point. Let me calculate. This is just a moment, right? You calculate m, moment about a point A, let's say, right? So sum of moments is what we require, right? So I want sum of moments. Let's denote this as summation of MA. Let's keep calculate and keep it ready for every force. You use this and all the other values to calculate the distance, right? The shortest distance from, as I told, you can measure this from one of the point. Since you have denoted A as your some standard point, right? You call this a distance from A, right? Distance from A means if you want to find the distance of the resultant from any point A on that plane is nothing but the summation of moments, summation MA divided by R. You see R is already calculated. Okay, all right. So that's the first thing, the distance. You can call this is some distance D, right? Distance from A. Okay. Next, the x-intercept. X-intercept of resultant, right? Let me, x-intercept is denoted by x coordinate, right? You can give x is equal to, right, summation moments about A at the point A, divide that by the y summation f1. So remember, for x you need to divide by y, right? And another equation, this is the y-intercept, right? Y-intercept of the resultant R, let's call this is y. Y is equal to summation MA divided by summation fx. So remember, x coordinate you need to use fy, y coordinate you have to use the fx for simplification. Okay, now all right, so these are the equations to be used. Let's proceed further. We'll solve a problem based on this. find the resultant of the following force system. Correct. Okay, this is 85 newtons. (68 newtons), 40 degrees. This is 30 newtons, 30. 25 newtons, 50 degrees. (90 newton), 70 degrees. This is 38 newtons at an angle 25 degrees. Okay, they also have mentioned about the distances from any sides. Distance of all the forces. So this is 4 meters. 6 meters. 3 meters. This is 4 meters. This is 3 meters. This is 3.5 meters. 6.5 meters. This is 8 meters. Two meters. So we have to find the resultant of this system, right? Looks pretty complicated diagram, but the solution is very simple, very straightforward. Okay. So now when this particular force system is given, you have to take any one side, right, with respect to what you find out, the resultant, because resultant is with respect to some point, right? We know that we have seen earlier, right? All the resultant we are trying to find out is with respect to some point, say some point A you need to identify. Let me take any one corner, say this is the point A. So my every answer is with respect to this point. From this point, resultant is located at this distance. Okay, from this point, right, the moment is this one. Like that, I have to calculate. So take any point A. So if they have mentioned something like, okay, find the resultant with respect to this point, a specific point which is marked by in the question itself, then you need to find there itself. Otherwise, you can find from any other point. Okay, now we can define any point we want. I'm calling this point as A. So I have to write what is the x and y component of each of the force, and I have to start solving for fx first, right? So let's try to write the equation summation fx. Equal to, start from this, right? I'll move all the forces like this and I come back. So every force I'll try to add. Okay, so first one is 85 Newton. It is going towards the right side and it is along the x-axis itself. So this is plus 85, right? Go to the second one. This is 68 Newton. So 68 Newton is actually making an angle 40 degree with the x-axis, and this is moving right towards the positive. So its component is positive. So this is plus 68 cos 40. Then the next force is 30 Newton. Okay, so this 30 Newton force is horizontal. So this is plus 30. Then there is a 90 Newton making 70 degree with the y-axis, right? So it is actually, right, if you look at the quadrant, this is the second quadrant case, right? So it is moving upwards, right? So and left, up and left means it is second quadrant. So over there the x coordinate is negative, so minus 90. Angle is with respect to y-axis, so this is a sine 90 sine 70. Then come to this, right, the 25 Newton, it is downwards and to the left. So if it is down and left, actually this is the third quadrant, right? So where the x component is negative, so this is minus 25. Angle is given with respect to x-axis itself, so cos minus 25 cos 50, right? Then we have another force, that is 38 Newton, right, making 25 degree. So this is right, upward and left means it is once again the second quadrant. So that is right, negative minus 38 into right y-axis, right? So finding the x coordinate, it is sine, right, 25 degrees. So this is coming as 50.38 Newton, right? That is the sum of the x components of all the forces in this, right? Very similarly, we need to find summation Fy, all the y coordinate. 85 will not come into picture because that is horizontal, no vertical component. Then go to the next one, that is 68 Newton. It is moving upwards, so positive. So this is the 68 Since angle is with respect to x-axis, I have to take the sine. So 68 sine 40 degrees. All right. Then again, I have a 30 Newton, which is horizontal, so I don't have to find a component. Let's move to the 90 Newton case. It is upward, so positive. So plus some 90. Angle is given with respect to y-axis, right? So this is cos 90 cos 70. Then moving further, there is a 25 Newton coming downwards, which is negative minus 25. Angle is with respect to x-axis, so it has to be the y component is sine 25 sine 50 degrees, right? Then there is a 38 Newton moving upwards, so that is positive, right? This is 38 25 degree with the y-axis, so cos 38 cos 25. Okay, we'll simplify to get the answer. This is equal to 89.77 Newton. Okay, we got fx, fy. Definitely we can find the r. So r and theta, we'll keep it ready. R is equal to under root fx square, that is 50.38 square, plus fy square, right? So that is 89.77 square. This comes to be 102.94 newtons. So let us use the equation for theta as this is tan inverse of summation fy, that is 89.77 divided by 50.38. So this comes to be 60.67 degrees. So now the problem with this answer so far is that if I don't find the remaining part of my answer, right, you can say that which is you cannot specify which is the exact force, right? R and theta are known. If so 100 Newton 60 degrees, right, that particular force can be anywhere, right? So something like maybe see this may be the answer, making 60 degree 102 Newton, right? Maybe the answer could be something else, right? I can say that no, this is not the answer. The answer is somewhere here. You see, that's also same, making the same angle. This can be somewhere here, right? Right? Any which is the exact force out of these many answers? Which is the answer? Actual answer we don't know, right? For that reason, you have to go ahead and calculate the remaining part as well. Okay, so first part is we'll find out the shortest distance. Right? What is the shortest distance from A? So we'll do that. So the distance from A, distance from whichever point you found. So distance from the point A, because in order to find that I need the moment. Sorry, I cannot directly do this. So let me go back and calculate the moment first. So let's calculate the moment of all the forces with respect to the any point. So right now I have taken that point as A. Any point you can take. You can even take the other corner, right? The right side corner, you call it as B, and you can do the same thing. All right. So let me. So my intention is to calculate this sum of the moments of all the forces with respect to a point A. Right, let's start with the 85 Newton. 85 Newton passes through that point A, so moment is equal to 0. Then move to the next one. So 68 Newton, 40 degree. I know that force is clear, 68 Newton, but the shortest distance is not available. Whenever we have such case, we split this into horizontal and vertical component. I know that horizontal component is going to pass through this 85, vertical will not pass, right? So we'll split this into only its vertical component and we'll use it. Okay, so the vertical component of 68 Newton at an angle 40 degree will be, right, the 68, right, angle is given with respect to x-axis, so y component will be sine. So 68 sine 40 degrees is this, into distance from point A is given there, 8 meters, right? So I'll write that is into 8. I just have to consider whether it is positive or negative, right? So if I consider the shortest distance like this and I apply a force like this, vertical component, this is going to turn this in, fixing this point at A. This A is fixed, let us assume. So whenever I fix this, I know that the distance, whatever is the shortest distance, right? Anything you place over there will rotate in a anti-clockwise fashion. So, right, according to our convention, the anti-clockwise is a positive. So that means this 68 sine 40 into 8 is a positive sign, right? So let's move further. Then we have, right, the 30 Newton. You see the 30 Newton is horizontal, but it is not going to pass through the 85 Newton. Sorry, it is not passing through the A. So when that happens, I can still calculate this. So, right, so this is, right, I think this is going to make it to road. Let's see that. So if I want to find the shortest distance will be somewhere here, right? So this distance is the shortest and that is given as 3 meters. So the distance is 3, right? 30 is perfectly horizontal and you can measure the shortest distance as 3 meters. So you can see that the calculation goes in this way. So I'll write a plus or minus later. So this is 30 into 3 meters. Force into the shortest distance of that from A. So 3 meters will be still measured over here. Okay, so both sides are 3 meters only. That's why only one side is given. I'll still extend that to the other side and I'll write the distance as 3 meters. Okay, now the next objective is to measure whether this is positive or negative. This is, the force is moving to right side. So if I hold something over here, it's going to rotate, it will rotate to the right. So rotating to the right in the sense it is clockwise. So clockwise will become negative force, minus 30 into 3. Right, let's move to the next force, that is 90 Newton. Again, it has, now I don't know how to find the shortest distance. So I split into horizontal and vertical. And after splitting that into horizontal and vertical, I still, right, I still find out that both the components are not passing through the A. Horizontal as well as vertical will not pass through A. So I have to write both components and the corresponding moments. So let us write the horizontal component now. Horizontal component will be, I'll mark with a different color. So let's try to write the horizontal component of this force will be something like this. So this is the horizontal component. Okay, and I'm going to have a vertical component, that also I'll mark. Maybe the vertical component is like this. Okay, so there is a vertical component. All right, let's see. Now, first I'm writing the horizontal component. So horizontal component, that component will be, this is 90 into sine 70. And what is the shortest distance? Is the distance from this horizontal line, and that distance is 4 plus the 3 meters. So 4 plus 3, 7 meters. Okay, so this into 7, and if I hold, right, I can see that this is going to rotate this anti-clockwise, so it is positive. All right, let's write another component. The next component will be, this is 90 into cos 70 into the, you see the shortest distance is horizontal complete distance because it is acting over here. So the distance should be this one. It is 8 plus 2. So totally 10 meters. The vertical component is over there and the distance should be like this. Okay. So let us try to write that. So this into 10 meters. And I know that this is going to rotate, right, anti-clockwise. So that is positive. So plus 90 cos 70 into 10. All right, let's move to the next force, right? Both the forces are considered. Now again, you see the 25 making an 50. Again, I don't know the shortest distance. You have to split it into horizontal and vertical components. And again, I will make a note that both the horizontal and the vertical components are not passing through A. So let's do something like this. This will be the horizontal component. Let me write it once again. So the horizontal component of this force is something like this. Okay, and the vertical component will be something like this. This is the vertical component. So I can see that both of them are acting at this common point. So both of them are not passing through A. So I have to consider the same thing, right? So in this case, the horizontal component is making this to rotate in an anti-clockwise direction. So the anti-clockwise direction means it is positive. So plus, so this is plus, so this is 20, right? Cos 50, I think 20 or 25. 25 is correct. So this is not 20, this has to be 25. So plus 25 cos 50, right? Into the shortest distance of horizontal is the complete vertical distance from here to here. So if you see this distance, right, the complete distance along y-axis is 6.5 plus 3.5, right? That is once again 10. Okay, so into 10, and this is making it to rotate left, means anti-clockwise, positive. Then the vertical component is going to make it to rotate downwards. So with respect to A, downwards means it is it's clockwise, so negative, minus 25 into sine 50 into the distance. Now you see the distance is with respect to y-axis, that is given as 4 meters over here. Okay, so you see the distance from the leftmost side wall is 4 meters. So when I say 4 meters, right, this has to be into 4. So this multiplied by 4. Okay, let's move further. We have another force, right? So the next force we have is 38 newtons. And with respect to that, again, we'll split that into two components, right? So the first component is vertical component will pass through A, so I will not mark that. Only we are interested in the horizontal component. So that will be writing vertical component passes through A, so you don't have to. So the horizontal component is 38 sine 25. So this is 38 sine 25 into the shortest distance of this is 6.5, which is given. So into 6.5, right? Into 6.5, that's the distance. And it is moving to the left, right? So left means it is, if I fix the point at A, left means the whole plane is going to rotate anti-clockwise. So this is going to be positive. Right, so this is the equation to find the moment. Let us simplify. This is equal to 1047.98 Newton meters. Okay, right. Now we got MA. Using this, we can calculate. First, you can find the shortest distance from the point A. That is MA divided by the resultant. Magnitude of the resultant. So that is 1347.98 divided by, I think we got the resultant as 102.94. So let us substitute that. 102.94. This is 13.09 meters. So the distance from, right, the shortest distance from A to this particular force, right, R is 13 meters, right? So out of many R's which can have the same magnitude and magnitude and angle, there will be only one force which is satisfying this condition. Okay, right. So dA is fine. Then we can also find out the x-intercept of the force. X-intercept, so that is x is equal to the moment about A divided by summation Fy. So this is 1347.98. Divide that with the Fy, that is 89.77. So this is 15.01 meters. Okay. Similarly, we can calculate the y-intercept of this force. That is y is equal to summation ma divided by summation fx. So 1347.98 divided by 50.38. 26.75 meters. Okay, so that is the answer required. So now this force which we are talking about is a single particular force. The magnitude theta at this distance with the x-intercept like this, y-intercept like this, if you say, right, give the specification of the force like this is a singular force. Okay, this is the only one force which satisfies. Right? Okay. All right, let's solve another problem of this type. Thirty Newton at 20 degrees. $60.75 newtons. Forty-five degrees. 45 degrees, 60.88 newtons. 76.97 Newton. .18 Newton at an angle 50 degrees. .35 degrees. .9617 Newton. And the distances are, this distance is 5 meters and 5 meters. This distance is 8 meters. This distance is 6 meters and this is 4 meters. This distance is 7 meters. FX ಎಷ್ಟು ಬಂತಮ್ಮ? 73.64 Newton. Okay, and summation of Fy 129.85 Newton. Okay, now next objective is to calculate the moment about the point A, right? Okay, now we can take any point as A. I'll still prefer to take this as A. Now the 30 Newton completely passes through A, so I don't have to consider A. Okay, then we'll move to the next one, that is 60.75 Newton. This is at a distance, so total distance is 10, out of which 7 is here, which means this side is 3 meters. Okay, so 3 is the distance and the force is 60.75. Directly shortest distance is available on the given diagram. So it is it is upwards. So with respect to A, it is anti-clockwise. So positive. So that is 60.75 into the distance is 3 meters. All right. Then we'll go to next force, which is this one, 60.88. Right. So that is, again, it is shortest distance is not available. We'll split this into vertical and horizontal. Okay, so let me try to write the vertical component. All right, if I want to write a vertical component, this is somewhere here. And if I try to write its horizontal component, somewhere here. Right, both are not passing through the given point, a reference point A. So I have to use both of them for the calculation of the moment. Right, so horizontal component is moving right, so it is going to act in this way. This is the line of action. Shortest distance is 4 meters from A. Right, it is moving to right, so anti-clockwise, so this is minus, right, 60.88. Horizontal component is sine 60, this thing into sine 45, and vertical into the distance, shortest distance is 4 meters, and vertical component is moving upwards. So with respect to point A, an upward force will rotate it anti-clockwise, so positive. Right, this is 60.88 cos 45 into the shortest distance is complete distance along x-axis. This distance is 7 plus 3, So totally that is 10 meters. Okay, so into 10. Right, let's move further. And on the top, we have a force of 76.47. It is horizontal. So completely it can be used, and it is acting along this line. So the shortest distance is complete distance from A, which is 10 meters. It is moving to the left, right? So any force that acts towards left will rotate this in the anti-clockwise direction. So positive. So plus 76.97 into the distance is 10, right? Then let's try to split this, the 30.18 Newton, and this is going to have say 2 components. So the vertical component of this force, the vertical component is here. Okay, so the vertical component of this force acts vertically downwards at this point, and the horizontal component will act horizontally like this. Okay, so both the components are not passing through A, so I have to consider them when I calculate the moment. So this is now, let me write the horizontal component first. It is from left to right, so it is going to act, it's a sign convention will be negative because it is clockwise, so minus horizontal component will be 30.18 into cos 50 into the shortest distance from A will be the complete y-axis, that is 10, right? And the vertically downward axis, that's also negative, 30.18 sine 50 into the distance along x-axis is 5 meters, so that is the shortest distance. Okay, so vertical axis, vertically it is going to move like this, so this distance I can measure as 5 meters. That is what is shown over there in the given diagram. Okay, then so both the forces are taken care of. Then we'll move on to the next force, that is 96.17. So this force, if you look carefully, right, again the shortest distance is not directly available, but I can definitely split it into horizontal and vertical, out of which the vertical component passes through A, right? Anything you draw like this, it is actually passing through A, so I don't have to consider that, right? So what we'll do, we'll write only the horizontal component, which is going to look like this, right? So I'm going to consider that for the calculation of the moment. So it is, right, acting to the right, direction is right side. So when I hold the point A, it is going to, the plane is going to rotate in a circular fashion, and it is clockwise. So this is clockwise, means negative, minus 96.17. Horizontal component is sine 35, right, into the shortest distance is 8, right? We finished all the forces, right? If you simplify this equation, we'll get the required moment, sum of the moments of all the forces at point A. Okay, this comes to be 9.36 Newton meters. Okay, all right. 3.077 meters. Okay. 3.53 meters. 6.23 meters. Perfect. All right. Then okay, next question. Okay, this is 60 Newton. This is 80 Newton. This is 70 Newton. This is 45 Newton. All right, now the angle is not given, first thing to note, and okay, so this is, there is a force here. I'll change the color because it overlaps with the okay. 75 Newton. 30 Newton. All right, so there are two more forces, right? Change the color just to highlight. Okay, now you see right here the angle is not given, right? But they have mentioned a different the distances in terms of slightly different mode. So they mentioned that, right, equally they are spaced. So 1 unit is horizontally, means this is 12, right? That is 12 units. And if you move vertically like this, then that corresponds to 15 units. So maybe meters, or it can be, right, centimeter, anything. So you can call it as units only, the meters, let's say. So 12 meters and 15 meters. Okay, so now you see, let's talk about the measuring of an angle, right? I want to measure several angles over here because I don't know any of the angles are not given. Okay, now, so if at all, let's try to mark some angles first, and then let's try to calculate. Okay, let me call this angle as, say, theta 1. This is theta 1. So how do you calculate theta 1? Theta 1 is equal to, I know this distance and I know this distance, right? Because vertically if you move, how much? 50. Horizontally if you move, it is 12, right? So I know now that I can use it to calculate, right, any distance. So vertically I have to move two squares over here, right? So 15 plus 15, vertically 30, horizontally 12, right? So you can use the tan ratio to find out the angle theta 1. So opposite divided by adjacent, right? Opposite of theta 1 is, right, I have to use the opposite of the theta 1 in the numerator and divide that by the adjacent. Opposite by adjacent is a tan ratio. So tan theta 1 is equal to opposite, which is 30, and adjacent, which is 12. This is going to vary from problem to problem, but right now theta 1 can be calculated as, it is tan inverse of, tan theta 1 is equal to 30 by 12. So theta is tan inverse of 30 by 12. You can calculate. All right, let's calculate all the such angles required. Then we can actually proceed. So this is theta 2. This is what I call theta 2. So theta 2 can be calculated. Once again, all ratios are tan inverse only. Look at the opposite of theta 2. That is this, right? So opposite is nothing but 15. What is the adjacent? For theta 2, adjacent will be this distance. So that is 12 plus 12 plus 12. That is 36. Right? Simply we can calculate. All right. So this is nothing but 36. Tan inverse of 15 by 36, you get that. Now let's go ahead. Calculate another angle. So I'll mark this angle as, say, theta 3. So theta 3 is equal to, once again, tan inverse of, right, opposite is this, right, opposite is 15. divided by adjacent will be this whole thing. So 12 into 4, 48. Get an angle. So then we'll mark theta 4 as, say, this one. Let me call this is theta 4. Theta 4 is measured with respect to y-axis. Opposite is horizontally this distance, right? That distance is the opposite. That is tan inverse of 30 divided by, so vertically I have to move, 24, sorry, not 30, my mistake. Let me correct. So this is equal to 24 divided by 45. Get another angle. So do you need any other angle? 1, 2, 3, 4. Okay. The 30 and 75 newtons are vertical and horizontal respectively. So the angles are with respect to this. It's perfectly 90 degrees and 90 if you want, right? So anyway, you don't want that. Directly you can use them. So find theta 1, theta 2, theta 3 and theta 4 first. Okay, theta 1 is 68.19 degrees. 22.29 degrees theta 2. Okay. Theta 3, right? Then 27.92 degrees is theta 4. Alright. Now, so we found what are the various angles. Now we can proceed in a very normal fashion to find the sigma of fx, sigma of fy. Then we can calculate r and the theta of the resultant, right, using the normal fashion. Okay. Sum of summation fx 161. Okay. This is 161.10 newtons. Okay. .90 Newton. So R okay, theta 12.40 degrees. Okay. Now we have to calculate the moment about any particular point. You can take a point, maybe this one. Okay, so I have to write equation to calculate moments of all the forces about A. So one force that is 60 Newton passes through this, so you don't have to write the moment about that. Then let us try to calculate the 80 Newton force. It actually cannot be, I cannot find the shortest distance directly. So my option is that I split this into horizontal and vertical component. So angle is given with respect to horizontal, that is theta 2, and I can split this into horizontal and vertical. So horizontal component will be moving from left to right. So let me mark the horizontal component. So horizontal component will be like this, vertical component will be like this. So you see that horizontal component is moving to right, vertical is also moving to is from top to bottom. So with respect to A, both will be clockwise. Right, so clockwise is negative, so both the components will generate a moment which is negative. Okay, so writing that, so this is minus 80, right? Horizontal component is cos, so minus 80 cos 22.29 force into the distance is, right? I know the vertical distance is 15, there is 1 unit, so 15. Then minus, this is top to bottom, so downwards, once again, that is 80 into sine 22.29 into the horizontal. Now, right, the distance is horizontal, it is acting here. So this distance, right, is nothing but, as per the given dimension, this is 12. into 12. So that's the first force. Then let us move upwards. So I have a 75 Newton over here. So 75 Newton is completely horizontal. So I can measure the distance also. Perpendicular distance is 15 plus 15, so 30. Right? It is moving to the right. So this is clockwise. So this is minus 75 into, right? What is the distance? 30. Then let's consider the 70 Newton. 70 Newton is, right, acting downwards, right? So it can also be split into vertical and the horizontal. So the horizontal force is nothing but, that is, it's going to rotate it anti-clockwise. So minus the 70, right? The horizontal distance will be, right, sine theta 4. So theta 4 is 27.92, right? That is the horizontal force acting over here, and the distance is completely 15 into 4, 60, right? And the vertical force is, right, again it's going to make it rotate anti-clockwise. So minus 70 into cos 27.92 into the distance is 2 units horizontal. So 12 plus 12, 24. Okay, then there is a 30 Newton acting upwards. So that is going to have a moment positive because it is going to rotate it in the anti-clockwise direction. And the distance, so this is 30 into distance is horizontal distance 12. Then we have a 45 Newton acting, right, to the left on the topmost corner. So anything which is rotating to left will have two components. One is vertical and horizontal. Both will rotate it anti-clockwise. So plus horizontal component is 45 cos theta 3. Theta 3 is 17.22 into the distance. Horizontal component will be 3 units above, right? So 3 units vertically is 15 into 3, 45. Okay, and the vertical component, that's also going to be positive, plus vertical component 45 into, this is sine 17.22 into vertical component will have a distance 12 into 4, 48. Okay, so we need to simplify this equation to get the total moment of all the forces at point A. Okay, this is equal to minus 4.08 Newton meters. Okay. Minus 27.57, right? Okay, meters. So the negative indicates it is actually outside the plane. Okay, it's not inside this, it's somewhere outside. Okay, that's fine. Okay, okay. X-intercept equals to 77 meters. So you can see that this comes on the other side. X-axis negative somewhere here. That's why it is outside. All right. Okay. Then let's write the y-intercept. Y is equal to 28.25 meters. You see the x and y intercept are actually y here, x here. So the force comes here. So that's why the distance is given in the negative form. Okay. All right. So anyway, this is the right answer, right? Using this technique, you can find out the solution of the equivalent or the resultant force of a concurrent, not concurrent, sorry, coplanar non-concurrent force system.